All right, I just wanted to recap what we did in class about friction. It's this idea that on a microscopic level, nothing is actually smooth. You've got these in, imperfections in the surface of the material, and when you try to slide one object over the other, so like for example, if this one gets slid over the bottom one, they're going to kind of grind against each other, and that's going to resist the motion of the top object. So, and then even on a more sort of exaggerated scale, if you look at this at the molecular level, you've got all these sort of atoms with their electron clouds in one surface and then electron clouds in the other surface. And those electrons sort of, when an object has been sort of sitting for long enough, they sort of arrange themselves in a way that provides a little bit of an attractive force there. So objects that are at rest relative to each other tend to be a little more stuck, so to speak. So you've got two factors here. You've got this stickiness when they're rest relative to each other, and you've got this idea that they're imperfect surfaces, so they bump and move across each other and cause a loss of energy and resisting to the motion. So the big takeaways from this idea is that the two factors that affect the friction on an object are how heavy the top object is, and we measure that in terms of the normal force that is applied. How hard is it? Really what I'm trying to say here is how heavily does it push down? How much force is the top object exerting on the bottom object? And this can be, so this isn't strictly the normal force, but it can be measured by the normal force. That normal force is a force that is pushed upward by the bottom object, in order to support the top object. So, and that force is equivalent. All right, and then the other factor that affects the friction is going to be the coefficient of mu, which is called the coefficient of friction. Okay, and it has no units. So once again, mu is a constant of proportionality. And what it is how sticky two surfaces are relative to each other. So it's the stickiness. I don't even know how to spell stickiness. And I would put this in quotations because it's not actually sticking together. It's sort of just the resistiveness, the stickiness of two surfaces. Okay, so those are the two things that we're dealing with. Now, that can be put together in this equation. Okay, force of friction. And this is a general equation that I want you to be careful when you use it, because there's two types of friction, as we talked about. There's static friction. And I'm going to use the symbol FSF to describe that. And this is when things are at rest. And then there's kinetic friction. And that would be FKF. And that's when things are moving or sliding. Moving or sliding. Okay, so this graph, what we talked about, is this idea that you gradually increase the force you're applying on an object over time. So if you increase the force you're applying on an object, what happens to the frictional force? So this is what we see. What we see is as your force increases, so does the frictional force. It increases until it basically, as you're applying more and more force, it increases and increases until the point where you're up here, and now you've actually maxed out the static friction that's available from this equation, this mu Fn function. So when you do that, now the object shifts from at rest to moving. So I can say at this point marks a delineation. Over here, it's at rest. And up until this point, and then over here and further on, it's moving. So in the first part, we're going to be using this idea that the frictional force, F, force of static friction, is going to be less than, let me write that better, is going to be less than or equal to mu s Fn. And over here, it's just constant. The force of kinetic friction doesn't change as you increase the force. It just equals mu k Fn. And the other thing to keep in mind is that when we look at this, the other thing to keep in mind is that for any object, so I would say mu s, which is the coefficient of static friction, is generally greater than the coefficient of kinetic friction, because it's easier to keep something moving than it is to get something moving. Okay, so things that are at rest relative to each other have slightly more friction. You have to overcome a greater frictional force, and that's what is going on in this graph when you see that the maximum value of static friction is actually greater than the value of kinetic friction. So so this equation up here with the star, I'll put another star, is the one we're going to rely on a lot. But just be aware that when an object is not moving, when it's static, this equation turns into this equation.